Okay, I said we're going to look at some logarithmic equations. Actually, we're looking at exponential equations and using logarithms to solve them. But we can also look at logarithmic equations and translate them to exponential equations. Depends on what kind of information we're given. Right now, we're going to look at exponential equations, equations involving exponentials. 5 raised to the x is an exponential expression. 5 raised to the x equals 7 is solved by first translating it to logarithmic form. So we would get x equals log base 5 of 7. That's really all there is to it, that and evaluating log base 5 of 7, which is log of 7 over log of 5, and approximately, not exactly, this is exact, this approximately equal to 1.2. So that was an easy equation to solve, but let's see what it might mean. Okay, well, 5 to the x. We could graph y equals 5 to the x. The graph might look something like this. Now, it's not at all to scale. My y-intercept ought to be about over twice as close to the origin as I sketched it, but we just take this as a schematic, not quite to scale. Okay, and we know the graph of 2 to the x. Okay, well, the graph of 5 to the x looks a lot like the graph of 2 to the x, but it's steeper. You can make a table and graph 5 to the x, just in the usual manner. You can do that. And see more accurately what it looks like. However, okay, 5 to the first power equals 5, 5 to the second power equals 25. So where x equals 1, the 5 to the x function will be equal to 5 to the 1 or 5. So when x equals 1, this function is equal to 5. So if we come up from x equals 1 and over, we'll be at y equals 5. And if we go from 2 up to the graph and over, we'll be at y equals 25. Now 25 would really be much higher, and so would 5 if this is the intercept. But let's not worry about that. Let's notice that the equation says 5 to the x equals 7. So for what value of x here, of course x is on this axis, and y is of course on this axis, I'm not going to label that. For what value of x would y equal 7? That's a solution to the equation 5 to the x equals 7. Well, we draw the horizontal line, y equals 7, and we see where that line intersects the graph of y equals 5 to the x. So we did that, we drew this, then we drew a projection line down here, and right there is our value of x. Between 1 and 2, but quite a bit closer to 1 than 2, because of course 7 is a lot closer to 5 than it is to 25. Now the graph has some curvature, so there are all kinds of things that affect the approximation we get, but if we have a graph of this shape, it looks like, I estimated the value would be 1.2, and actually it came out very, very, very close to 1.2, but you know, you might, from the picture, you probably would have said 1.3. And that's okay. We need to see in the picture what this equation is telling us and what the solution is telling us. So the value of x is clearly going to be between 1 and 2, and despite the fact that the graph keeps getting steeper, it's probably going to be closer to 1 than it is to 2, because 7 is so much closer to 5 than it is to 25. And remember, how do we get 5? That's what happens when x equals 1, that's what we get, and 25 is what we get when x equals 2. Okay, so there's a picture of this equation essentially, and a picture of an approximate value of x, and this is just a much closer approximate value of x, much more reliable. Okay, now another equation. Okay, we come over here. Now the equation is 12 times 2 to the x equals 50. Now this is not in the form b to the x equals c, but we do see it's an exponential. We've got a 2 to the x here. We have to have 2 to the x equals just some expression. Okay, we can't have 12 times 2 to the x equals something. So what do? Well, we divide both sides by 12. Okay, and that's going to leave us 2 to the x. Now, we had people who tried to subtract 12 from both sides. instead of dividing by 12. And that's just an inattention to what's actually going on. If you subtract 12 from 12 times 2 to the x, you don't get 2 to the x. Okay? You can't get rid of that 12 by subtracting it. You have to divide by 12. So you get 12 times 2 to the x over 12, and of course you divide this side by 12. So we divide both sides by 12, and then to emphasize why you divide both sides by 12, some people want to just cross these out and cancel them. Well, that would be a valid cancellation, but I always regard valid cancellation among classes where a lot of people try to solve this by subtracting 12 as very unreliable, okay? If we don't understand that we divide by 12 here, and the majority of people do understand that, but if we are even capable of subtracting 12 from both sides to solve this equation, we don't deserve to be canceling things, okay? And it's not that you're horrible people and don't deserve it, it's that you are taking a big chance when you cancel. There's a very high probability you're going to do some wrong cancellation, okay? Now, as I say, it would have been right to cancel here, but I don't talk about canceling for the very reason I just talked about, okay? You got 12 times 2 to the x divided by 12. Well, that's the same as 12 divided by 12 multiplied by 2 to the x. And 12 divided by 12 is what? 12 divided by 12 is 1. So that's just 1 times 2 to the x. And 1 times 2 to the x is just 2 to the x. So we get left-hand side is just 2 to the x. Now what about the right-hand side? The right-hand side was 50 over 12. Now down here I say that's 4 and 1/6. That's one way to do 50 over 12. You divide 12 into 50, you've got a remainder of 2, so it's 4 and 2/12, which is 4 and 1/6. More direct, we could have just said, well, 50 over 12 is 25 over 6, which is of course also 4 and 1/6. We can say 50 over 12 is 4 with the remainder of 2, which is then 4 and 2/12. And 2/12 reduces to 1/6, so it's 4 and 1/6. So we can do the right-hand side. We can write it as 50 over 12, 25 over 6, 4 and 1/6. Well, the way that's most direct, if you're going to punch it into a calculator, is 25/6. And so we say 2 to the x is 25/6. It's easier to punch that into a calculator than it is 4 and 1/6. Of course, you could punch in 50 over 12, but it's just better form to reduce it. Okay, so from this equation, dividing both sides by 12, we end up with 2 to the x equals 25 over 6. Now it's in the form b to the x equals c. b is 2, x is x, c is 25/6. So we translate this into logarithmic form. X equals log base 2 of 25/6. And this is our exact solution. Now, we key that into the calculator, and of course we do that as log of 25 over log of 25/6 divided by log of 2. And we get this 4 significant figure approximation. It's only an approximation. This is exact, this is an approximation. Okay? Okay, well, we do one more equation. Okay? I did 5 times 2 raised to 3x minus 7 equals 3. People did pretty well with this. Okay, well, you saw that after what we did here that you divide both sides by 5, and you get 5 over 5 times 2 to the 3x minus 7 on this side. And on this side, of course, your 3 is divided by 5, so you have 3/5. So you get the equation then, 2 to the 3x minus 7 equals 3/5, which you can pretty much see directly from here. If you divide by 5, the 5 goes away, you end up with 3/5. But you want to be careful that you're doing it right. Okay, so we have then 2 to the 3x minus 7 equals 3/5. What does that tell us? Must have been in a hurry when I wrote that down. Okay, this tells us that 3x minus 7 equals log base 2 of 3/5. We just translate this statement into logarithmic form. It's log to the base 2 of 3/5 equals your exponent, which is 3x minus 7. Now, maybe a little confusing that you have a 3x minus 7 in your exponent, and the formula over here happens to use x for the exponent, right? Well, this just says, well, we have to replace x with 3x minus 7, okay? Because we have 2 to the 3x minus 7 equals 3/5. 2 is clearly your b, 3/5 is clearly your c. The place of x has been taken by 3x minus 7. So that when we put it into this form, the place of x is taken by 3x minus 7. So we get 3x minus 7 equals log base 2 of 3/5. And I had to move all the way over here. So here is the equation, okay? And here I've repeated it. Okay, 3x minus 7 equals log base 2 of 3/5. What do? Well, we have to get x. We're trying to solve for x. But this equation is easy to solve for x, and the class saw this immediately. Said, well, add 7 and then divide by 3. Okay, well, I don't have room to go through all the details I did over here in dividing by 3, so I just wrote down the steps. Clearly, if we add 7 to both sides, the negative 7 here will be added to the 7 to give us 0, and that goes away. So we have a plus 7 over here, but the negative 7 over here is gone. Then if we divide both sides by 3, well, 3 divided by 3 is 1, and 1 times x is x. And then we divide this whole expression, log base 2 of 3/5 plus 7, by 3. And then to key that in, we have to put that in the form log of 3/5 over log of 2 plus 7, all that divided by 3, using this rule. Now, to key this in, you're going to want to put, okay, this really isn't very good mathematical form, but this will work for your calculator, and I don't want to address the algebra of, or the arithmetic in this case, of expressing this as a simple fraction. It's actually a complex fraction, but we can deal with it. The thing we need to do is put this numerator in parentheses. So you would have this numerator in parentheses. The numerator would be parentheses log, parentheses 3/5, parentheses after that, divided by log parentheses 2, and that parentheses, and then plus 7, and the outer parentheses, and then that divided by 3. Okay? And hopefully you know how to use your calculator well enough to do that, but that's a little bit of a complicated expression, so it's something we're probably going to have to look at a little more. When that's done, you get the value of x, and you find that x is about, it's pretty close to 2, but it's a little more than 2. Then we can kind of check that with what we have here. If x was 2, it's a little more than 2, but if x was 2, you would have then 2 to the 3x minus 7. Well, 3 times 2 is 6. 6 minus 7 is negative 1. That'd be 5 times 2 to the negative 1 equals 3. Well, 2 to the negative 1 is 1 over 2. That's 1/2. Half of 5 is 2.5, as I hope we understand, which is pretty close to 3. If x is a little bigger than 2, then this is a little less than negative 1, and this will be a little more than 1/2, and it's probably going to work out, very plausibly going to work out, that this equation is solved when x is just a little better than 2.